In the last video, we discussed the concept of the antiderivative. And just to review, if we have, this was the example we used, if we have, actually it should be little f of x equals 4x cubed, and this was our derivative, what was the original function? The original function was capital F of x equals x to the fourth, and then of course we need that plus c. All right, so the process of finding the antiderivative is called integration. Let's write that down. The process of finding all antiderivatives of a function is called integration. Okay, so there's a new term, integration. And one thing to keep in mind is that a lot of times integration and antidifferentiation are considered synonyms. So when you're find the antiderivatives, integrate this, you do look at it the same way. All right, now we're going to come up with a new symbol in calculus. And so, I mean, this is the second big concept from calculus that we're learning. You know, the first big concept was derivatives, and the second big concept from calculus is integration. And so we have a new symbol for this. So let's write it out. The set of all antiderivatives of f, so some function f, is the indefinite integral of f with respect to x denoted by, okay, so we're going to have this thing called the indefinite integral. And the indefinite integral is finding all the antiderivatives of a function with respect. And we're going to denote it by the following. We're going to have a new symbol here. Okay. And then we're going to put f of x dx. All right, so you might have seen this symbol in the book, or you might have seen it in, you know, people who've taken calculus in previous years. You might have seen and wondered what that is. And what this is this is the integral sign. Okay. And then the f of x is our integrand. And then the d of x is the variable of integration. So what we're doing in this class is or in this video for this unit, is we're looking for the indefinite integral. And so to indicate that we want to find the antiderivative, we put this integral sign in front of a function, and then we put this dx. Now, in this case, you know, for this class, it's always going to be f of x and then x here. So these variables will match. You know, in later classes when you take multivariable calculus, for example, what's in here and what this x or what this letter is, or variable is, could be different. But that's not going to happen in here. We're pretty much just going to keep these, you know, if this is x, that's x, if this is t, that's t, and so forth. Now, we do have this indefinite integral. We are going to have a different type of integral. It's going to be called a definite, just so you guys know, but we won't work with that right now. But just so you know, when we have an indefinite integral, that means we're going to have infinite solutions. All right, now we don't have to worry so much about those infinite solutions because all we do is we just add a c, and so therefore we take care of that infinite solutions. So now we can do the following. We've been working with this example, this f of x equals 4x cubed. So now we can officially write the following. If we want the integral of 4x cubed dx, so let's say you see that on a test, or you see it in the book, or you see it somewhere. This is actually a question. And this question is asking you to find the antiderivative of 4x cubed. And when you do that, you end up with x to the fourth plus c. And so now we have answered our first integration problem. And so we can kind of write out this in general terms. The integral of f of x dx equals capital F of x plus c. And that is the concept of an indefinite integral. You're given a function. You know this is the derivative of a function, and this integral sign is telling you we'll find the antiderivative of that. Okay, so now let's kind of combine derivatives and integrations together, and I like doing this. This is kind of a neat little way to look at how it loops around. And what we do is we say, well, let's start with this. Let's say we had y equals x to the fifth. And let me take the derivative of y. So dy dx equals 5x to the fourth power. Now, I'm going to take this dy dx equals 5x to the fourth power, and I'm going to multiply each side by dx. So we're going to end up with dy equals 5x to the fourth dx. Now notice that this 5x to the fourth dx looks really similar to this f of x dx. Okay, and there are, they are related. How this works. So now what I want to do is I want to integrate both sides. Okay, now I'm going to talk about this later, but the integral of dy is just y. So don't think about that one too much. But what's the integral of 5x to the fourth? Well, we actually know what it is. It's x to the fifth, because if the derivative of x to the fifth is 5x to the fourth, the integral of 5x to the fourth has to be x to the fifth. Now, of course, I forgot to add a plus c here, and a plus c there. Now, the reason I forgot to add a plus c here is because we're going to take this plus c, bring it with that plus c, and we end up with y equals x to the fifth plus c. Now, these two plus c's are not the same. We can't assume that. So we end up with this. But this kind of shows how we started with the function, we took the derivative, we were then able to separate our dy dx, take the integral, find the antiderivative, and end up with plus c. And so this is a big concept that derivatives and integration, so the derivative and integration process, they're inverses of each other. And just like logarithms and exponential functions were inverses of each other, we have this inverse process, and it's an extremely important inverse process. Okay, so in this video, we looked at this new term called integration. We have an indefinite integral, and integration and antiderivatives, a lot of times they're synonymous. You can use each one back or forth, but I would say in general we talk about finding the integral of a function. And so now we have a new symbol, and that new symbol is telling us find the antiderivative of that function.